Well, hi, and welcome to my shop this morning. It's an interesting morning in both the United States and Canada because the tornadoes of truth are blowing in both countries. So Mr. Cohen's going to be testifying. I had to pry myself off the TV this morning. But here in Canada, we have our own, I don't want to say conspiracy, but concerns over some actions that our federal government took in relationship to the to another. I won't go into it. To another part of the government, there's some questions been raised and ethics questioned and all this kind of stuff. So here in Canada, there is something similar going on, but not really. Nothing is similar to what's going on south of the border here. Okay, so okay, a couple comments before we get going. Number one. The tube that I'm using in the tester at this point, rather than the 6L6, is a 50L6. This is a dramatically different tube in terms of its operation from a 6L6. A number of you have sent me emails warning me that some disaster is looming if I continue on with this tube. I don't think so. I think this is the name of the game here is just be aware of what you're doing, and I think we can get along fine. I don't really know because I have not done the actual alignment steps. I haven't done them ahead of time or anything. I haven't done them yet. So today we'll be attempting to do the next alignment, did I say alignment? The next calibration steps. If it turns out after I check into it that the 50L6 is just not going to do the trick, I'll find another tube. I believe the reason the 6L6 was picked was because that tube draws a lot, and they wanted a tube in here that draws a lot of power while you're doing some of these calibration steps. And yeah, this is nowhere near the power of a 6L6, but not to worry about it yet. Not to worry about it until we need to. Now, as for the rheostat, which I spent yesterday trying to resurrect and salvage, I think its demise is guaranteed at this point. I don't think there's anything I can do to this that's going to make this thing work reliably into the future. So the replacement is on the way. It's coming from Britain, and it'll be here probably in about 10 days. So I'm going to continue with the machine as it is, with the wrong tube, with the wrong rheostat, finish off the process, which I might be able to finish it today. I think there's only 2 more steps. Another thing that's happened here, and certainly this is a bigger concern when the new rheostat comes, I'm assuming that this is a linear rheostat. It sure looks that way. It's one piece of wire wound around it. How can it be anything but linear? And the one that's coming should be linear also. But there's a couple of different things that go on with this control. One is setting the bias level based on the meter reading. Doesn't really matter what is in here as long as I get that reading to where it needs to go. But when the EM test is being performed, as I read and as was pointed out to me by one of you, the EM test is dependent upon the, let me show you what I'm talking about here. You see that? Yeah. Dependent upon this scale that is marked here. So if the potentiometer I put in here, or if this potentiometer is not working linearly, properly, smoothly, then, and it wouldn't matter if you're reading the voltage up here, it will matter if what you're doing is reading off this dial. So that's a little bit of a concern. That's for the EM test. You know, I've never thought much of EM tests, but having read more and more about this tester, and the you know, the marketing angle on this tester was that it would do both tests, the EM test and the GM test, and to make the sale, the developers of this suggested that in some tubes it's more important to do a GM test, and in other tubes it's more important to do an EM test. And you see, that makes sense then to get a tester that can do both. And that's what this guy is, the tester that can do both. And putting the bias voltage up on the meter is another attractive feature of this thing. Really attractive. Well, that's enough talk. One more thing to say. There's more than one of these in here, like a dummy. I didn't really think about it, but there's another one sitting right here. conceivably it's exactly the same inside. This is a different value, a radically different value over here. So when I first noticed this, I thought, oh my god, maybe I could have done a swapping thing. No need for that. I am not going to spray WD-40 in here. Shame on me. Yes, shame upon the house of Jim for spraying WD-40 into something like that. You know, I could have popped the top off and looked inside before I sprayed it. I made a decision. It turned out not to be the best. But that's how it goes. Well, I think I can't do much with this thing upside down. I think we've got to flip it right side up and start following the instructions. So let me get everything all set here. That's enough talk, don't you think? Okay, let's take a look at the instructions here. So the last step I was performing, I was just getting ready to start step M when the problem with the rheostat for the bias showed up. So I really never made it past here. I just got here and then disappeared into the strange world of the rheostat. So I did perform all these last things. I did reconnect this wire appropriately. So I think we're right at this step here, which I've done. Return return the wire back to lug 14 or 13, whatever it was. So I think I'm right here. Rotate plate shunt switch to C. 8K. Repeat steps B, C, and D. B, C, and D. Rotate plate shunt switch to C. Repeat steps B, C, and D. B. So put into test mode. Just line. Wait a minute. No. This isn't right. I'm not supposed to put this test switch to hold and put this on line. Wait a minute. Is this what that? This is remove the 2K resistor. Well, we should follow exactly what it says here. Now I'm concerned that, in fact, I don't have the machine in the proper state to go forward from, where was it? Where am I? Man. Here we are. This is where I am. So the question is, can I just carry forward onto this? B, C, and D. Just reading here quietly to myself. Well, repeat C and D. So it's the line and bias adjustment. That's really what this is. This is just getting the line and the bias set. I mean, they could have said that in English down here. Repeat steps B, C, and D to set bias and line voltage. Rotate meter switch to test. And note GM reading on 8K scale. Well, there's certainly, if you could throw the meter switch to test and make a reading, then that means the test switch is in the hold position, didn't it say put it in the hold position? I'm so hung up on these things now. The test. I thought it said hold here somewhere. Oh, it's up here in B, C, and D. Right. Rotate test switch to hold. Meter based bias. That leaves it on bias. Rotate meter to test. I think I'm overdoing it here. I think I'm overdoing it. Okay, I think I've got the picture here. Not 100% sure, frankly. I find those instructions really hard to read for some reason. They just seem to not, every time I read them, they just don't seem to really soak in clearly. So you can see I've got a couple meters hooked up now. I've got this meter hooked up to read the filament voltage, and then I have this meter over here connected to read the grid potential. So we don't have to rely on this meter necessarily. And this will give me a chance to double check if I set the bias here, does it really show up there? That's the question. My meter's switched on here. And I'm kind of interested in seeing what the voltage is on the heater too. And I'm assuming it's just putting an AC voltage onto it. Probably a very good assumption, in fact. Okay. Now, is this really set up for a 50L6? I think it is, but let me just quickly double check. B. First instructions. Yeah, okay, hold on. Just stay with what you're doing, Jim. BGAG. BGAG. This is in material. This is the other potentiometer, by the way. 06431. 06431. 05200. 05200. I'm going to start with this on the line setting. This on test. Bias low, but not at 0. One of the things that concerns me about a rheostat in a situation like this is when you approach the limit, there could be a little tiny bit of resistive wire in there, and at that point the watt dissipation of that little bit of wire is not enough to cover what's happening. Now that shouldn't be the case. They wouldn't normally design this to, you know, turn the control. It burns up. But that just worries me all the time, especially with the replacement one I've ordered. Because I don't really know what kind of current is flowing through this. I don't think it can amount to much. The broken wire in the wire wound resistor, no current is flowing right through it. So it's still a mystery to me why this is working at all. 10, I think we're all set. No, almost all set. 123. Hey, waiting for more snow today. There's a lot of snow now on the ground in Aurelia. My wife and I drove down to a city called Pickering, where my son lives, and that's down on the north shore of Lake Ontario. It's about a 90-minute drive from here. And as soon as we got out of Aurelia, we noticed that there's not nearly as much snow anywhere. So, hey, Aurelia, snowfall. Well, here's what it looks like outside my house this morning. So I'm one of the few people who's got a black driveway in Aurelia. So another 5 or 10 centimeters and maybe more snow is coming a little later around dinner time or so. I think we're set here. Turn it on, Jim. This is set to 50. Watch for 50. What's beeping as it crosses 25 volts. I have the dim lights in here in case you're wondering why everything is going kind of slow. We'll take the lights out. Everything looks fine. Lights out. Now let's see what we actually get. Oh my gosh, is that ever accurate? I'm floored. We do the line adjust. Let's just see how much precision. So this is showing exactly correct. If I wanted to make this 50, turn this. Oh my gosh, it's hardly. I'm talking a half a degree turn there. This is now ever so slightly below the 10. This is probably a better way to calibrate this. I should probably get in that 5 volt thing and adjust it now to make this say 50. Pretty cool. It won't hurt the tube for me to knock this down to 6.3 for a moment, or will it? Will it? No. We'll knock this down to 6.3. I want to see if 6.3 is 6.3. Okay, so now this has gone a little high because we're not driving as much current through this tube anymore. So whoop, wrong control. I'll just turn. That's easy mistake there. So if we put this right on where it should be, 6.5 instead of 6.3. But you know what? This is not drawing very much current because it's a 50 volt filament. If you put a 6 volt filament in here, it would draw more current and drop this voltage to 6.3. Excellent. Let's go back up to 50 here. Don't go past. So now this is dropped lower because there's more current being drawn, but it's really time to set the bias voltage. Oh, I'm looking at this meter's pinned backwards because I didn't do that. Okay, bias voltage for a 50L6 is supposed to be 1.4 volts. So flip this on. Well, let's make this line correct first. Yeah, wrong control. I'm going to do that a lot. That's okay. So line is, or let me make this 50. That's good. It's very close to being perfectly straight up. Good. Bias. Flip this to bias. 10 volt scale. The bias here is showing as essentially nothing. Why would that be? Oh, there it is. Okay, now we'll look at this meter. We're on the 5 volt scale here. Wow, there's a huge difference between these readings. A huge difference. Wow. So, just because I never mentioned it earlier on, it's always my intention at some point to hook all kinds of meters up to a tube under test and verify as you do these settings that what you would hope shows up on that tube really does show up. It's not enough to read this meter and have it say 1.4 volts and you can't know because of that 1.4 volts is making it over here. And apparently it isn't. Let's see. I'm definitely on the 5 volt scale here. So you can see it's over 2 volts. The fact is, setting this to 1.4 is way up from there on this meter. Way up on the 50. Well, this isn't even changing. Does that mean that this voltage is not actually impressed on this tube until you push a button or something? Bias, test, test. Well, we're going to have to find out. So we'll flip this to test. Set the bias roughly to what it's supposed to be. 1.4. So on this meter it's 2. You know, that's roughly right. On this meter, read the scale right. On this meter it's 1. Yeah, you know what? 10. I'm not reading the scale right. On this scale it's 1.4. 2, 4, 6, 8. Yeah, just above 1.4 on here. And here, this is just above 2. Is there some chance that the number they give you to set this meter to is not actually the grid voltage? You set this so this meter reads 1.4 and you get what you need to get there, which is something different. I can't imagine they would do that. That just sounds nuts. I'm sure they would want somebody to read the actual grid voltage here and have that in your head. Okay. Okay, so this is set. Well, we'll leave this at 1.4, although even though it says 2 here. Go to test. And we'll run the test. Is that right? Am I right? Am I right? I didn't check for short, so I'm not worried. Let's run the test. Notice this voltage drop down. On test, this voltage over here goes up. Isn't that weird? I think if I put this on bias and then throw this to test, I'm not sure what I'm doing. I'm not. Would the meter just continue to read the bias? Look at that. What good is that? And I flip this to test, the bias goes up. What exactly is happening here? As I vary the bias, yeah, it does not reflect on this meter. Did I really get this meter connected right? Force back to square one again. JJKL. To think, people used to test their own tubes in drugstores mostly. You'd go in, there'd be a tube tester in there, you bring your tube in, stick it in. Your tube's no good, you want a new one, you grab it out of the shelf down below the tube tester, take it over to the cashier, and pay her your 11 bucks. And walk out with a tube. Now if people can successfully test tubes like that in a drugstore, for crying out loud, how come I can't do it here? Yeah, 6L6, I don't think I want to look at that. I kind of totally lost, I'm losing my cool. Losing my religion here, that's what's happening. L6, what does it actually say here for a 50L6? Grid number 1, typical voltage -7 when operated with under fixed bias, 110 volts on the plate. Put 200 on the plate. Oh, that's cathode bias. That's just showing how to do it with cathode bias. They don't come out and give you a voltage. So -7.5 on a 50L6. Yet this is saying to run the test, oh, I got a static shock there, 1.4 volts. And the actual voltage appears to be closer to 2, but then when I go to run the test, the voltage changes. Oh my gosh, let's hook up another meter and get even more confused. So the test result here, are we still at, we're nowhere near 1.4 now. What happened? What happened here? I probably just wiggled this control at some point. 1.4. And didn't we get 4 or something? I got 6. I got a GM of 6 here this time. On the 20. 6,000. Didn't we test this at 42? And if I do that again, 50 becomes 49, 48. And the bias voltage goes from 2. Oh, that's right. I was going to check and make sure I got the wires on right. I'm sure I got them right. So, I mean, this is clearly the heater. So the other one, I'm trying to read between the cathode and the grid with the VTVM. 50L6. So it should be between 8, pin 8 is the cathode, and the control grid is 5, and that's certainly where I've got it. 8. Got one pin covered here, so it won't short. 1, 2, 3, 4, and it's definitely on 5. There's just no question. By the way, if you haven't noticed yet, I've got a tube extender on here, and thank you to the viewer who sent me 3 of these tube extenders here, which have proven to be quite handy. So that's why it has these terminals I can clip on here and make these measurements. We could go another step and add more confusion by trying to monitor the plate voltage. Well, I'm this far into it, let's go another step. Let the truth be... Yes, that's right. The tornadoes of truth are blowing everywhere, including in my shop today. So if we want to read the plate, it would be plate relative to cathode. Let's see if I can get on here without... Okay. And I don't want to hold this on, so I'm going to clip it on. I see the day a few days from now where I'm going to be doing this with all these tube testers in a way that can compare them. So plate, plate, plate. Positive. 150, 500. I gotta plug that guy in. I still haven't put my VTVMs back in their home locations. L6 again. A fellow gave me this book when I was working full-time in the very early 80s. He knew I was interested in this stuff and brought this book in. Now watch what I have to do with this meter. it's going to time out, so I have to reset it. Maybe I'll just push one of these other buttons to reset it. Well, that reset it all right. Okay, what I was going to say is I don't dare turn this control with the leads hooked up. I want to turn it off, turn it back on to reset it. I'm just so panicky about doing that with the leads connected. So I have to pull one lead off. The whole thing becomes dangerous at that point. One of these terminals pulled out, still connected to a circuit, hanging free while I'm fiddling around with this. This is not a good meter for in this shop. Mostly because of that confounded beeping. Okay, focus, Jeff. Focus, 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 focus. 3. Pin 3 is the plate. Clipping on with this thing operating. Pin 3. That's 2, this would be 3. So as soon as I hook this up, this meter should jump up. Should jump up. No jumping upwards. Oh, because maybe you got to push the test button to apply the voltage. Okay, let's see. Does that make the voltage jump up? There it is. Okay, so we're on the 500 volt scale. So that was about 125. Let's just check it again. No, not 125. About 105. So on the 150 volt scale, 150 volt scale. So this is reading now 132, 130, about 130 volts. What's going on over here now? So that's still dropping. So now what I want, I'm going to continue just fiddling around here, just getting a feel for this guy. I'm going to put this on line. I'm going to watch the line meter when I do these tests, and I suspect what's going to happen is the meter's going to go down. Okay, so I got to keep it on line. Come on, Jim. Here we go. Line voltage drawdown during test. Now, it never ever says anywhere in the manual, at least I hadn't noticed, where it says put this on hold and readjust all these the bias in the line. Wow, that's an interesting question then. That is an interesting question. Are you supposed to put this thing into test mode and then bring up everything? Bring up the line voltage and check the bias? I got to read the manual in more detail. I got a lot of reading to do here. Yeah. So it could well be that the designers of this, when the test is implemented, they look at the result, and that becomes the result they write in their book. Something like that, if you know what I mean. And then that's the result you compare to when you do the test. And the result itself is actually not quantitative as such, although it would appear to be. It's just when they did the test, they got this amount. You know, it's the very same as saying to people, if you're going to use a low impedance meter, or more, to word it better, in some alignment instructions for radios and that, it will say these tests were done with a meter of this sort. And what they're trying to say is the result you will see on your meter will only be exactly the same if you use a meter just like ours. Okay, so the result you will see on this meter is the result you will see when you perform the test the way they told you to do it. And perhaps the way they told you to do it, pay no mind to this problem of the line falling and everything falling when you hit the test switch. Because that's what happened on the original machine too, the one that they worked all this stuff out on. And so the result you get is the result you get. I have to read the manual more carefully. But I think it's interesting to note, and it's not surprising. After all, there is a dim bulb in this thing. This thing here. This is basically a resistor right in the 120 volt, right in this line. So it is a tiny amount of voltage dropping here that's being lost in the rest of the machine. And as the machine's draw varies during the test, the drop here varies. So we're talking about a small amount, but I suspect this is what causes the instability in the operation of the tube tester. That's why this line check thing becomes so critical. It's because of this. To be more specific, it's not just a matter that you're matching the line voltage in your house. You turn this once. This is how I always thought about it. You just turn this once. Okay, now we're matched to the line voltage, and then you forget about it. That's how my other tube testers appear to work. But this one continually directs you back to readjusting the line voltage to get it to where it needs to be to make the test accurate. Man, live I talk a lot, eh? That's good though. This is why I do these things, to make my brain tick over. And where is the bias voltage at this point? 1.4, but on the other meter it's still just under 2 volts. Wow, it really raises lots of questions. For instance, one is, if I pull that tube out but leave everything operating here, what will happen to this? Will this go up or down? I think it shouldn't go anywhere. But you know what, I'm not going to try to pull this out. Trying to pull this out, I got my fingers all around these clip leads. One of them's going to shock me, so I'm not going to try doing that. But that's an interesting question. And then the answer would be, of course it would change the voltage, because you take off the heater draw, the drop on the fuse light changes, the voltage this thing's operating with changes a little bit, and you'll see that reflected in the meter. All these things are only critical if this guy really has the potential to be exactly what it says here. Actually, it's not precision we're after, it's accuracy. We don't need precision in this, we just need accuracy. So they should have named this, oh, I see why they named it precise, because who, accurate? What can you do with that name? Marketing department probably worked on it for a long time but gave up. Well, I'm not getting an awful lot done here, am I? So the next step is supposed to be making adjustments so the GM reading is the same on 3 scales of the meter. Let me go ahead and do that. Flip this to test. Now, I'm just going to review quickly what I'm doing here. Oh my gosh, where am I in this list of stuff? Here we are. Rotate plate switch to C, 8K. Repeat steps to set line and bias. Rotate meter switch to test note GM reading on 8 scale. 8K scale. Rotate. Oh, so take the reading. So we take the reading on C. Okay. Okay, let's try that. Now this is a different tube here, but I don't think it's going to be critical. C. GM. Nice reading. All meters are. Oh, well this what happened here? Oh yeah, that's right. When you hit the switch, the bias voltage goes up. It goes up from 2 to 3. So the bias voltage is currently 3. So the whole test is kind of invalid, isn't it? Invalid. Sorry. There. Okay. Let's bias 2. Yeah, I see it goes up. Wait a minute. It's not in test mode. Yes, it is. It's in test mode. Wow. The fact that you can do this is kind of neat. That's kind of neat. Okay, so on the 8 scale, our reading is 5100. That's what I make that out to be. 5100. Better write it down. It's got 4 digits in the number. I'm going to get it juggled. 5100. Quickly. Find something to write it on. Here it is. 5100. Okay. I'm Fortunately, there's other numbers written on that piece of paper, so the chance of me getting confused is still pretty good. The next step, now we're going to switch it to a different scale. Rotate switch, GM reading, rotate plate shunt to 20. Hold on a second. Hold on a second. So this thing is set up with this on here. So the whole thing's set up, bias is set with it here. Then it says flip the switch to here, repeat the steps. Oh, I didn't repeat the steps. Repeat the steps, man. Oh, okay, so this shouldn't be in hold though. Okay, well, I'm doing this without this in hold. Who knows if I'm doing this right? 1.4 on this meter with the backwards dial. That's 1.4. Okay, it's exactly the same on that other meter, just under 2. Wow. Could be a lot of bad resistors in here, and that's why these things aren't quite working out. I don't know. Line again. Line is good. Bias is good. Test is really hard to see. What the heck? Oh, I've got this set wrong. Back off. Oh, this. Oh, you know what I did? Oh, now twice I've done this now. You get these two controls mixed up. I just got these two mixed up. Part of this is because I have a TV screen to look at, so I'm not just looking here. I'm looking up at this TV screen in my shop here, and I think that's causing this. These are bad mistakes to make. Bad. Okay, that's a little better. GM coming in a little bit higher. 5300. So I got my choice now. More numbers on the page. 53. Flip this down. Is this 53? No, it's 58. So I make an adjustment to make it 53. And the adjustment is, oh, what's going on there? Okay, rotate meter switch. Oh yeah, to test. That's what I've got on hold actually. And adjust potentiometer P7 to get the same reading. P7. 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 There it is. Okay, I'm ready to get the same reading. The reading was 53. Turning this now. Oh yeah, look at it. You see the meter moving there? So I'll set this to 53. So now we're on the B scale, 20 scale. 53 would be. Smells like something's getting warm in here. 53. A little bit more, a little less, a little less. There. I think the line adjust control is getting quite warm. Yes, it is. To be expected. Particularly while this is on test. So we'll take this. Because you know that kicks down the current a little bit in here. It'll kick down the current coming through this. Yeah, so don't leave things in test for long periods of time, or I'm going to put a little cooling fan on this. So that's it. All that talk today all amounted to me adjusting one little thing. And did he do it right? Okay, I go back to yeah, I'm just going to leave that. We'll go back to the other scale, read the GM, 52.5, change scales on the meter. Beep. Beep. And on this, we are now on the right, 2053. Okay, so that worked. And the bias voltage is 1.4 and the line voltage is just a hair low. All that for that. Oh my gosh. Hold on, there's more. There's more. Okay, P8, 30K. Same thing on the 30K. Okay, let's go. Flip this back to test. Flip this back to hold. Flip this down to 30. Good luck trying to read that little tiny thing there. And the adjustment now is P8. P8. A little bit of an awkward spot there. Okay, P8. Now on the 30 scale, which is the same as the 3. Oh my gosh, I want this to be 5,000. This control is at its limit. It's at its limit. It only goes down from here. It doesn't go up. It does not go up. There's hardly anything on this meter. So where would 53 be if you're on the... You're supposed to be reading 30,000 at the top here. So, and I'm trying to see 5,000 of 30. So 5,000 of 30, that would be up here. It would be here. It's way low. It's way low and it can't get there. Watch your fingers, Jim. You're going to get a shock. It can't get anywhere near it. Okay, check off. Bias. 1.4. Line. The line has gone way low. What's going on there? What's going on there? It's moving around. So I was wiggling a screwdriver underneath. Okay, so I don't know what happened. The meter was kind of falling around there. I don't know. So if the line is off, it's not off by much. This control is getting pretty warm down here. Line. Bias. Test. Hold. And the meter barely lifts. There's something wrong on this scale, I think. Off. And pull the screwdriver out of there. Leave it. Power off. Hubba 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 hubba. Okay, there's a whole pile of stuff in my head now. The biggest thing is this meter, the 30K scale or A scale, doesn't seem to be working properly. Plus the control was at its limit, but it was at its, yeah, it was at its limit to make that meter come up as high as possible. So I would say the last guy going through this, if there was such a thing, when he got to this point, he cranked that up as high as he could, and that was the end of that. That's hardly a way to get this thing in to be accurate. It'd be wonderful if when I'm all done, I can, without any doubt, read a bunch of stuff, including plate current. I have other ideas about what I could do with this machine to soup it up. There was one more test. We should have tried the current test here to see what kind of current was flowing through there. But to save that for next time. So I apologize for this being a little slow and very stumbly. Then again, what is it I do in here that isn't slow and stumbly? So I think I got to leave it there at this point. Yeah, because I've completed another section, and the next section, in fact, in the manual here, proudly announces you have now completed the calibration of the GM section of your instrument. Well, not quite. The next thing is emissions calibration, and in this case, using a tube other than the 6L6 may present some problems here, and plus I've got this control reversed. There's lots of problems with the next test, but I can probably perform it and just see that it kind of goes through the motions okay, without any precision or accuracy. We're pretty much done. So that's the next two things: emission calibration, filament current calibration. Okay, well, thanks a lot for watching, and listen, lots of fun is coming, because once I get these machines all working the way I want them to, I will be able to master any tube put in front of me. So I think. Right, okay. Well, I'm going to go wait for the snow. Thanks a lot for watching. Sorry for all the talk. But that's today's episode. See ya. So you can see a couple of our visitors there, a couple of squirrels on the ground. That's below our bird feeder. It's up above. So bird feed falls to the snowy ground here. And also we give them peanuts all the time. That's why they come around our house. We have a lot of squirrels that come here every day. Down on the bottom right of the picture you can see my weather radio. Oh, there they go, squirrel chase. Whoosh. Whoa. Quick, bail out. Well, thanks again for watching, and it won't be long before the snow starts falling here.